we get through these notes, there will be no homework. But I got a worksheet ready to go if I need to give homework. So everybody pay attention. And we'll get through these notes, and there will be no homework. All right, so in this case, in 1990, the population of the town was 5,000. In 2018, the population is 6,000. If the population grew exponentially, what was the rate of population growth? Okay, these are going to be different because do you see a percentage anywhere? We don't. That's a problem for us, right? Because so far, everything we've done, we found it gave us the percent so we could write our equation. Now this one, we can't do that. We need y equals a times b to the x, but the only thing we have really is our a, or that we can find easily. So we know y equals 5,000 times b to the x. Okay, so 2018 minus 1990 tells us how long has passed, right? 28 years, right? I think. So 28 years has passed. So this is what we've got to do for this problem. After 28 years, what is the population? It's 6,000. And so in this equation, y stands for population. Right? So y stands for population. So we're going to put 6,000 over here for our y. Equals 5,000 times b to the 28th power. Alright, so we have got to find that b. So we're going to solve this equation. And I've got to teach you something that you don't really know about yet, and you're not going to totally understand, but just take my word for it on how to do it, okay? So the first thing we're going to do, we're going to divide by 5,000. So we're trying to get that b right there by itself. So we're going to divide by 5,000. It's the only one we're going to do. All right, so let's back up just a second. So are we okay with this? We know 5,000 is our original, right? We're okay plugging that in. All right, and so we don't know b for this one. We can't find it because we don't have the rate, so we have to leave b there. So what we're going to do is we do know that after 28 years, in 2018, that the population had gotten up to 6,000. So we can plug in 28 for our exponent because that's where time goes. And 6,000 goes over here because that's the answer you would get if you plugged in 28. All right there? So if you plugged in 28, you would get 6,000 if we knew what b was, right? So we're going to put that over here for our y. Because in this equation right here, y stands for our population and x stands for our years. And then a is our initial value, that's our 5,000. So in this equation right here, y is population, b of x is years. So we know in 28 years, the population is going to be 6,000. So we plug in 28 for our years and 6,000 for our y. Okay. So then it's a process of solving that equation to find the b. So, b is the growth rate or the growth factor that you have there. So, like if we knew the percent, this is where we would take 100% plus the percent and move the decimal, but we don't know what that percent is here, so we can't find it. But that's what it is right there. That's 100 plus the percent moves the decimal, but we just don't know what it is yet. Okay. So to solve for b, it's pretty much going to be the same process every time. We're going to do some more of these. We would divide by 5,000 or whatever number is here to get rid of that 5,000. So that gives us 1.2 here. So we end up with 1.2 equals b to the 28. And then we have to raise this to the 1 over 28 power. If you don't really get that too well right now, don't worry about it too much. Just know you got to raise it to the 1 over whatever power right there. Because whenever you do that, when you do b to the 28th power to the 1 over 28th power, like Miss Hendrick was showing you, you have to multiply those exponents. Like if you had a squared to the 3rd, you'd multiply 2 times 3 and you'd get a to the 6th. So here, if we do that, we've got b to the 28 times 1 over 28. And so if you multiply those fractions together, you get b to the 28 over 28, which is just b to the 1st power, which is just b there. Okay, so it's always going to be 1 over whatever exponent you have there because it makes it 1. And so if you do it to this side, you got to do it to this side. And you'll have your calculator to do that because we don't know how to do it by hand. So you'll do that in the calculator. That gives you your b. Okay, does it make more sense? Okay, and then once you get b, that's still not your answer because remember whenever we find b, we have to take 100, we have to add the percent, and then we have to move the decimal. So we got to go backwards from that. So that's why I moved the decimal 2 places, got 100.65, and I subtracted that 100, so it gave me 0.65%. Because whenever, like normally, like if they had told us that the answer was 0.65%, then we would have done 100% plus 0.65%, and that would give us 100.65. And so then we'd have to move that decimal 2 places, right, to make it 1.0065. That's how we did it on the other problems where we knew the percent. So that has already been done here. We've got to go backwards if we want to answer the question of what the rate was. So we move that decimal to change it back to a percent, and then we subtract the 100, and that leaves us with the rate that we would have there. Okay. All right, we're going to do some more of these. They're definitely more difficult than the ones that we have been doing so far. Okay. We'll do some more. All right. Okay, so here's another one. This one's even a little bit trickier. A little bit. So, not too bad though. Pretty much the same as the last problem. Scientist begins with a sample of 20 bacteria. Actually, no, this one's different. The bacteria double every 30 minutes. How long will it take before there are 1 million bacteria in the sample? Okay. So, this one has enough information to write the equation. Although it doesn't really look like it has enough information to write the equation. Because I don't see a percent anywhere. Alright? I do not see a percent. But, I do know the initial value. So, Evan, what's the initial value going to be? 20. Because the scientist begins with a sample of 20. And then, I do know what the B is here. What's the B? It's not 30. It's not 60.
40.
None of those. The number is not there. It's a word. Double. Right there. It doesn't tell you the percent increase. It tells you it's doubling. So if it doubles, what are we multiplying by?
2.
Just 2. Just 2. Just 2. Okay? To the x power. But you got to be really careful here. Okay? Y is the number of bacteria. X. Okay? X, what does it stand for? Hours, minutes, days? Not minutes. It's more complicated. How often does the bacteria double? Every 30 minutes. So X is your number of 30-minute time periods. Or you could put half-hour time periods. But so, example, if I asked you how many bacteria there would be after 1 hour, what number would you plug in? No.
40.
If I ask, so number of bacteria after, it's not asking you this, but I am, after 1 hour. No. How many 30-minute time periods are in an hour? 2. Okay? So you would do 20 times 2 to the second power. Be 4 times 40. 4 times 20, which would give you 8. Do your exponent first. Yeah. Okay? Alright, so what about if I said the number of bacteria after 5 hours? Okay? I do 20 times 2 to the 10th. How do you get 10, Evan? Right, so it takes 2 30-minute time periods for each hour, right? So there'd be 10 30-minute time periods. If you think about, you guys live in a world where you don't have to watch commercials like I did growing up. But growing up, on regular TV, it's still, if you watch regular TV, it still happens. But on, with all the DVR and all the Netflix and all that, you don't understand quite like I did. But, right, but whenever I was growing up, every show was always 30 minutes. Like, all shows lasted 30 minutes, just about always. So you would have a show from 8 o'clock to 8:30, and the new one would start 8:30, or sometimes there would be hour-long shows, but most of the time they were 30 minutes. So if you were going to watch SpongeBob, you'd watch a 30-minute episode of SpongeBob. So I always think of this as how many 30-minute TV shows could I watch in 5 hours. But you guys watch a lot of stuff like Netflix where it might be like 23 minutes and 47. So you don't understand it quite like I do. You're right. You guys watched regular TV when you were little. Your cartoons were. But I'm only about 10 years away from having kids that have never just watched shows with commercials and normal TV. It's crazy. Alright, now, this doesn't answer the question, though. Okay. Alright. New question, though. How long will it take before there are 1 million bacteria in the sample? So I could keep, guessing, right? I could just keep guessing. 10 didn't work, so I try 11, 12, 13. I could keep guessing. Or I can put this in my y equals and look at the table, and that's what we want to do. So go to y equals on your calculator. Everybody try it. Make sure you can do it. Adam, take that hood off, please. Thank you. Alright. So y equals is right above that blue button. 20 times 2 to the x power. Okay. Y equals is right above the blue button, that top corner button, top left-hand corner. Alright, everybody got theirs in? Okay. Alright, we're going to press second graph to get to the table. Second graph to get to the table. And depending on where you're at, you're going to have to scroll up or down. And, alright, if you're in negatives, you're probably down here at these. You don't need those. Don't worry about those. Go on up here. Alright, so right here, this is 655,360. Then it goes to 1.31E6. That's scientific notation. Here's a trick for you. If you click the over button, it'll give you the normal number unless it's so big that they can't even fit it there. So this is 1,310,720. So 15 to between 15 and 16 is when we get there, right? But what is it? Hours, minutes, days?
Hours.
All right, what did X stand for?
30 minutes period.
All right, so we have 15 to 16 30-minute time periods. Okay? So for this, Evan is right, that's 7.5 to 8 hours. So somewhere between 7.5 and 8 hours. And for this, if I ask this question like this, I will take any answer that's between 7.5 and 8 hours. This will not be on the quiz on Monday. The quiz on Monday is going to be it's going to be the same quiz that you guys took not last week because I wasn't here, but the week before. So it's going to be that same quiz. You can actually go into Canvas and look at the quiz so you can see the questions. I am going to put the questions in a different order so that you don't remember like number 15, this is what you do. So I'm going to put the questions in a different order, and they run on like a formula, so it'll give you different numbers in the question, but the words will be the same. Okay, but it is just the percentage stuff. It does not have this on the quiz. It doesn't even have any of the exponential equation quiz stuff yet. We'll probably take a quiz on it probably Wednesday. But on Monday, it's just a retake of that percentage quiz. So please go look at that percentage quiz. And I will be here Monday if you want to go over it. Okay? All right, questions? All right, here's our next one. All right, Jennifer invests $5,000 in an account that gets 6% interest compounded annually. How long will it take her money to double? Okay? So, we can write the equation for this one. This one, we know how to write the equation for. So, Ian, tell me how to write this equation. Not 0.6. 1.06 to the x power, right? Y is our money. What does X stand for here? We're compounded annually. Annually means X is going to be years. Okay? So, this is fine, but we could guess. We could say 5 years, 6 years, 7 years, but it's a lot quicker if we put it in our calculator, right? So let's go to Y equals 5,000 times 1.06 to the x power. And we go to our table. So you go to Y equals, type it in. Then you do second graph to go to the table. How much would she have if her money has doubled? 10,000. So we're looking for when it hits 10,000. It's between 11 and 12 years, but it's closer to 12 years, right? Because at 11 we have 949.1. So I will take anything between 11 and 12 years. It's probably, like a good guess would probably be like 11.8. You can always check. You could go 5,000 times 1.06 to the 11.8. And that gives you just about 10,000. Actually be a little more you could do. Let's see if we did 0.9. If you needed a more specific answer, you could do this. 0.9 is really close, right? Probably like 11.89 or something like that. You could keep going with that as far as you wanted to actually find the real answer, but we'll take this close enough. Okay. Sometimes I'll ask you in which year did the amount of money or exceed $10,000 or first exceed $10,000? So then you would answer the number just 12. That's the first full year that it had went above $10,000. Sorry. Hey. Yeah, let's see. I'm just curious. Let's try like 8, 9. No. Let's try 8, 9, 5. Oh, so close. 8, 9, 6. We'll count that. It's the extra 19 cents. But if you really wanted to be specific, 11.896 years would be close. Most of the time, a general idea is going to be good enough for us. When you get to Math 3 and learn how to do logarithms, then you can find the exact answer. But we'll just say 11 to 12 is good enough. All right. Okay, this one's almost the same problem, but it's weird. Kaylee invests the money in an account that gets 8% interest compound annually. How long does it take her money to double? Oh, that's the problem. We don't know how much money she has. All right. So I need everybody to do this real quick. Make up how much money Kaylee has. I want everybody to make up a different number. Everybody make up a different number. So just make up. I would suggest using numbers that aren't quite so huge just because it makes it easier to see. So you could use $1. Or you could use $160. But I would probably pick 1 or 100 or 200. Okay? So make up how much she makes and do the same thing we just did and see how long it takes the money to double. Alright, make up how much money she makes and try this. This is our last one. Everybody gets it done. You don't have any homework. Make up the number for the initial. So, for this equation, it doesn't tell us how much money she starts with. So we're just going to make up a number. So you might say she starts with $100 or $1,000 or $20. Alright, so the equation would be, how much money you want her to have? $2. What was our least value? Okay, alright, so several of you made up different numbers here. Julie over there had 2, so 2 times 1.08 to the x, oh, that's not the x, to the x power. Okay, between 9 and 10. Now, watch this. Evan used the number too big. Somebody else. Monica, what did you use instead of 2? 10. So, 10, go to the table. And right there between 9 and 10, that's where she had $20. Okay? Somebody else that didn't use too big of a number, give me what they used. 100? Alright. Look what happens. $200 between 9 and 10. It does not matter how much money she has. It's going to take the same amount of time to double. So 9 to 10 is your answer for that. Okay? Go ahead and pack up. We'll finish these up and we'll do a worksheet to practice it Monday after we take our quiz. If you're having trouble with percentages, come see me Monday so we can work on it. Hey, come see me. We'll work on it to make sure you're good on that quiz, okay?